Hello guys, welcome to today's lesson on GeoGebra. So today we want to look at statistics and then we'll also look at the basic concepts in probability. In statistics, we want to look at linear regression and analysis. So with linear regression, we know that linear regression is a statistical method that models the relationship between a dependent variable and then one or more independent variables. Getting into it, we also look at correlation and know that correlation is a statistical measure that has to do with the relationship between the two, but also it deals more with the direction and the strength of the variables. So when we start, we would want to change our view of GeoGebra and make it into spreadsheet. So spreadsheet, and then we can close this. Now, we'll have to take a question to go to get into this. So now let's go to Word and take a question from there. So now let's copy this data. Let's copy this data and paste it here. Command plus V. Okay, so now that we have this, we can look at it. Okay, so now we have our variables to be X and Y. X happens to be our fat, and Y happens to be calories. So then let's look at the question again. So the question, they are saying that a nutritionist collects data on the fat content in grams, so the fat content and calories several items. The data is shown below. Now they want us to plot a scatter diagram. They want us to draw a line of best fit, and then we'll use the GeoGebra thing to find the regression equation. So let's get into it. So now we have to highlight these rows in the spreadsheet. After highlighting, we come here, select two variable regression analysis. We ask GeoGebra to analyze for us. Now we can open our scatter plot wide so that we get to see the view better. So now we can see from here that the regression model is none, but we are dealing with linear regression analysis, linear regression. So we have to come to this side and choose linear regression. So now we can see the line of best fit. So the line of best fit we have here passing through the points, all these points. Okay. Now we have the equation for the line of best fit. This equation for the line of best fit is y 10.6065x plus 158.362. So now that we have this, if we were told to find the number of calories when we were given the fat to be, let's say 40, this is what will happen. Now x now becomes 40 in our given equation. So to be 40, we press enter and we get the market. So anytime that we are being asked to find the number of fat or anything, we have to just manipulate this x to get our y. Manipulating this x to get our y. Okay. So now that we have this, so you can see this line of best fit and everything. And if we want to find the correlation between x and y, we come to sigma x. I realize our correlation is 0.958. With correlation, when it is 1, it is very strong, it's a positive correlation. And when it's negative, right now it's a strong positive correlation. When it's negative, when it's in the negative, it's a strong negative correlation. But then we have regression. So we have our correlation being 0.958, meaning that we have a positive relationship, okay? And having a positive relationship, when it's exactly 1, you can say you have a perfect relationship, but then because it's 0 point, it's almost 1, you can say you have a strong positive linear relationship between x and then y, okay? So now we've seen how to go about this. We've seen how to go about linear regression and correlation. You are being given your independent variable and dependent variables and how to go about it and how to interpret your correlation, and also how to go about a line of best fit, and how to manipulate the equation of line of best fit to get a y values. Now that we have this, we can go ahead to look at this. We can go ahead to highlight these things and go to one variable analysis. Ask to analyze. Okay. So now that we have our analysis being done over here, you can see this graph, and then this graph consists of the plotting of x and y. So we have our x here and our y here. And looking at it from this statistics, we have our standard deviation and all that. But then our focus today is on the linear regression or correlation. Now we want to look at basic concepts of probability. So now let's change our view from the spreadsheet. Let's change our view to probability. So now what we can do is we can close this. Or simply let's open a new window. Open a new window for that. Okay. So now I want to look at basic concept of probability. Basic concept of probability. Looking at basic concept of probability, let's change the view that we have here. So we can close this and we extend this. We extend it. So when we go to the basic concept of probability, realize that we have a normal distribution. Okay, a normal distribution. And looking at this normal distribution, let's see if it's a normal distribution. It has a bell shape, so you can see yes, it is a normal distribution. And then this normal distribution now becomes a standardized normal distribution because it has its mean, that's mean being 0, and its standard deviation being 1. Okay, and then one other characteristics of a standardized normal distribution is that the mean, you can see that it is symmetric about the mean. That is the mean is at the point of symmetry. So now, right now, if you draw a straight line through this, you can see that it will be at the peak of the normal distribution. So the point of symmetry is at the mean. Okay, the point of symmetry is at the mean. Now we've seen this about the normal distribution, but today we want to talk about binomial distribution. Okay, we want to talk about binomial distribution. So with binomial distribution, let's take a question and we get into it. So binomial distribution, it's a question on grade. So we have our question here. Now that we have our question, so the question, we were told that a die is rolled 7 times. What is the probability of getting at most 1/6? Okay. And then we have our question 2 being a die is rolled 5 times. What is the probability of getting at most 2 5s? At most 2 5s. So when our n becomes 5. So we are saying that a die, we have our n to 5. And then we have probability, because it's a die has 6 sides, okay. So the probability of getting it to be 1 out of 6. 1 out of 6, or 1/6 enter. So now we have this. And then the question asks us to find what is the probability of getting at most 6. At most 2 6, okay. Enter. So the probability of getting at most 2 6 is at the 0.4098, 0.409, 0.1608. all these. So when we add them, we get 0.9645. And so this is, so on the binomial distribution in display here, the probability of getting at most 26, this is it in the view. Okay, so let's move to the other question. So we can also look at, if we were asked to find what is the probability of getting at most, let's say 7, at most 7. So we can edit this to 7. 7, enter. So the die can be, let's say if the number of times the die shows 40 times, the number of times of getting at most 7, enter. Okay, so now we have that here. And if we want to for the number of times of getting 8, we have that here. Number of getting 9 and all that. So the number of getting, let's look at the question. Let's take a question to that. So today we've looked at probability, and then looking at probability, we took a question and we looked at the binomial distribution. We also looked at the normal distribution, how it's based. So when we get to this part of the display, we have looking at the normal distribution, chi squared, f, gamma, and all that. And then so you look at just the features of normal distribution. We also looked at the features of a normal binomial distribution. We took some questions there. We also looked at linear regression and analysis. So I'll bring my lesson to an end. This is where we end for today's lesson. Next time, we'll also go to another topic.